as we're getting pretty close now to Thursday's vote on Britain's future in Europe, I wanted to put some thoughts together that I've had. It's been a pretty brutal campaign, really. There's been a lot of nonsense stated by both sides. The economic arguments have gone back and forth. Both sides claim that their argument is the stronger. Economics isn't really my thing. I can't say I'm sufficiently familiar with the principles or the models or the historical precedents that they use in order to construct their completely contradictory ideas. So I'm going into an area which likes to avoid contradiction, which of course is science. The most important result of 2015 was without doubt the detection of gravity waves by the LIGO experiment. I think the Nobel Awards over the next year or two will back that assertion up. It was experimental confirmation of the final component, major component in general relativity. Without gravity waves, the theory would have been wrong, and the technology to detect them was now coming along, so we would have found one way or another, if we were right, in the next few years. As it turned out, once again, the theory turned out to be bang on. In fact, within a few weeks of the initial observation, another observation was made, so we've now firmly entered the new era of gravitational astronomy. The successor to LIGO is a space-based interferometer called LISA. LISA will be able to operate at a much wider range of wavelengths than LIGO. LIGO can only detect objects which are relatively small and relatively nearby. LISA will be able to detect more than that. At this moment in time, an experimental prototype test module is in orbit, and so far it's only in its testing and commissioning phase, but it's already 100 times more accurate than it was expected to be at this point in the project, which means that when LISA is finally built, it won't be just detecting objects that are nearby. It will be able to detect supermassive black holes up to the edge of the visible universe. So what we're going to learn from that device, we have no idea. I mean, it's going to be incredible, the things we find out. But LISA is a European project. It's part of the European Space Agency. For me, the idea that human beings are currently in the process of altering atmospheric chemistry really isn't up for debate. We've industrialised the process of producing vast emissions. We're talking about changing levels of a trace gas in our atmosphere, because we have the technological capability to do that, and that this trace gas has an effect on the total energy budget of our climate systems. That's not up for debate either. The physics is really quite elementary. So to deny these things, you've either got to be a liar or willfully ignorant. The solution is obviously we need to stop oxidising carbon and start finding power from other places. Now, a big part of that is going to be fusion. It is going to be fusion. The whole universe is powered by binding energy. That's how everything out there is powered, or at least everything that's not powered by gravitational potential, I suppose. But as the human race, we need to be powered by that as well. Now, fission is the same. If you take a uranium atom, you split it into a smaller atom, there's a little bit of leftover mass, which is the binding energy, strong nuclear force, the gluons that mediate the strong nuclear force. The bit left over, that gets liberated directly as energy. So you split a big atom, you get leftover mass, that gives you energy. If you fuse light nuclei together, you get some leftover mass. That's what you do in a fusion reactor. You're taking a very available material, which is deuterium, fusing it with tritium, and creating power. It's going to be how we do it. The largest project in the world at the moment is ITER. It used to be the International Thermonuclear Experimental Reactor, but they dropped that now. And it's been built in Europe. It's an EU project. It's the flagship EU science project. So Britain's contribution to it is via the EU. The EU is 46% of the funding for that project. Every industrial nation in the world is paying into that, but the EU is almost half of it on its own. by far and away the largest contributor. The biggest, most important experiment to back up the work at ITER would be the Joint Experimental Tokamak, which is in Oxfordshire. It is the largest, most efficient and most powerful fusion experiment that we've built so far. It's an early European collaborative project as well. When the different European governments were looking at building this thing, it was either going to be built in Germany or built in Britain. And in the end, a brilliant political solution was found. It was built in Britain, but with a German director for the Institute. So both governments were able to say that they were an important part of this massively vital future technology. And that's really the thing. This is about collaboration. This is not about money. People have said that, oh, if we leave the EU, then there'll be no money for the science, or if we don't give money to the EU, we can put it into our own science. It's not about the money. It really isn't. Most of the science that's been carried out in Britain isn't funded by the EU. Most of the science carried out in the EU isn't funded by the EU. It's funded by national governments, it's funded by major institutes, it's funded by commercial operators, by big businesses that need new technologies. The Galileo GPS system is currently being built. It's the most accurate GPS system of them all when it's fully operational. It will allow people with their phone to have navigational information to sub 1 meter resolution, and specialist operators using techniques that have been developed for surveying with the American GPS will have sub-millimeter resolutions. That's a European project. There are several satellites up at the minute. They're part built in Stevenage, behind B&Q. Because we're part of it. Because we're part of all this. Carl Sagan daydreamed on television once about what we would find the next day on the surface of Mars. What life forms we may see moving around on the surface of Mars. On the eve of the Viking mission landing on Mars. Now, obviously, there was no life forms there. But it was equipped with a laboratory which could dig up the soil and analyse it and look for biology, look for molecules. It didn't find any. Now, in science, that's not a failure, because the experiment was delivered to Mars, it was run on Mars, it transmitted its results on Mars. If you do an experiment and the experiment gives you results, that's a success. But from the wider perception, the public and a political perception, it was a failure because they went to look for something, they didn't find that something. In science, any result is a success because it's data, it's knowledge, you've learned something. The next major mission to Mars is the ExoMars rover, which should be landing in 2020. It is going to look for life. It is looking for biological signatures. That's the biggest experiment on there. The Americans haven't dared to send another experiment looking for life for 40 years. But ExoMars is going to look for it. It's an incredibly optimistic act, and it's a European project. The most famous instrument of them all is probably the Large Hadron Collider, which is in Europe. The different countries that donate money to it. Britain is number 3 in the list of countries that give money to CERN. We have scientists at CERN. We have scientists in institutes throughout Europe and throughout Britain who are doing work on the results that come from that device. If anything is going to replace the current paradigm in physics, the quantum paradigm that was born in the early 20th century, with a new 21st century physics, it's going to come from the Large Hadron Collider. That's where we're going to get the glimpses of the stuff we do not have an explanation for. It's a phenomenally important instrument, and we play a major part in it. You have to remember, with all the economic argument that's been going on, we are no longer an industrial economy. We're now a post-industrial economy. We don't turn out millions or billions of units of cheap items. They're made elsewhere. We turn out a small number of very high value units, very high tech, very specific products, which aren't generally available. They can only be made in the most technologically advanced nations. And Europe, certainly the large economies in Europe, Italy, Germany, France, are major parts of that. they also have massive industries. British Aerospace is the third largest defence contractor in the world. Airbus Industries is the second largest aerospace company in the world. Those are big, high-tech industries. Every Formula One car on the grid is manufactured in Europe. That's state of the art. It doesn't matter where the country, where the team is supposedly from, whether it's a manufacturer which is from the Far East or from the United States. Their cars are designed and built in Europe because that's where that hub of knowledge and technology is. Britain has always been a country of innovation. The Industrial Revolution was born here. The sheer number of devices, technologies and techniques which are part of everyday 21st century life, which originated in this country over the last 200 years, is phenomenal. We're a very small country with a very large impact. And we're at the leading edge of science. Britain as a country, or Britain as a population, our scientists, they published 90,000 academic papers last year. That's third in the list of countries that print papers. China's population is 20 times ours, and they did 115,000 papers. So we really do make a big, big impact. We've been at the front of world science for decades, but we've been at the core of European science for decades, and European science is at the front. It is leading the world in so many areas of research that are going to be vital for the rest of this century. And the idea that we can reject Europe's premier institution, that we can reject Europe's biggest political project, and yet still retain our privileged position, is just a delusion.